Hello and welcome to today's class. My name is Dr. Wanjala Titus. Today I will be taking you through statistics and probability. In the previous class, we were able to look at the moment generating function of a normal distribution. And before we continue, if you haven't subscribed into my channel, then please subscribe so that in case of a new knowledge, you'll be the first one to be notified. And therefore, we were able to derive the moment generating function of a normal distribution. And today, we are going to derive the mean and variance of a normal distribution using the moment generating function that we derived in the previous class. Therefore, in the previous class, we said the moment generating function is given by the exponent mu t plus a half sigma squared t squared. And therefore today, we want to derive the mean using this one. Therefore, before we derive the mean, we must know that the expected value of x, which is representing the mean, we are going to find the derivatives of the moment generating function with the limits t heading to 0. So our derivatives is going to be the moment generating function but t heading to 0. That's how we are going to derive the mean using the moment generating function of a normal distribution. Therefore, we will be able to say the moment generating function is going to be given as the derivatives of the moment generating function. But with the limits t heading to 0. Are we getting it? Therefore, this one, we already know what it means by this moment generating function, which is this one. So, our expected value of x is going to be the derivatives of the exponent mu t plus a half sigma squared t squared. Are we getting it? Therefore, let us differentiate this function. This means we are going to differentiate the power, then we multiply by the original equation, which is, now we differentiate mu t plus a half sigma squared t. We are going to get, when we differentiate this one, we are going to remain with mu plus, when we differentiate a half sigma squared t squared, these two will cancel with this one, so we'll remain with sigma squared t. If we differentiate this one, we get this one. Then we multiply by the original equation, which is exponent mu t plus a half sigma squared t squared. Are we getting it clearly? But we said we differentiate with the limits t heading to 0. Then, in reaching there, it's now easier. Let us replace the values of t with 0. Wherever we see t, we replace with 0. Then we start by having this is going to be mu plus this one times 0. 0 will give us 0. Are we getting it? Then we say this one, it will be exponent. Are we getting? Mu t is going to be 0 plus a half sigma squared t squared. It means this one is also going to be 0. Are we getting it? So this one, we are going to remain with mu into the exponent of 0. But remember, recall the laws of indices. Any number raised to 0 is always 1. So it means this one is going to be mu multiplied by 1. So our expected value of x, or the mean, is now going to be represented by mu. That's how we derive the mean using the moment generating function. Therefore, let us head towards the second derivation of deriving variance. How do we derive variance? We said variance, or the expected value of x, is always given by the expected value of x. Subtract the expected value of x, but all squared. Are we getting it? But remember, this one, expected value of x, we have already found it as the mean mu. So already it's mu. So our major part of concern is this one. So how can we write? How are we going to write the expected value of x? We need to derive that one. So that one is also given by the second derivatives is going to be given by the second derivatives of the moment generating function with t heading to 0. Are we getting it? And this, how can we find out the second derivatives of the moment generating function? Then, the second derivatives of the moment generating function, we always use the first answer we got here. This is now what we are going to derive to give us the variance, or the expectation of x squared. Then this one is going to be the moment generating function, or the first derivatives of the moment generating function is going to be the second derivatives of the moment generating function is going to be the differential of the first derivative, t heading to 0. Are we getting it clearly? Then in doing so, our first derivatives gave us mu, this one, that is our first derivative. It gave us mu plus sigma squared t, then the exponent mu t plus a half sigma squared t squared. Are we getting it? Then what to do is we are going to use the product rule. Under the product rule says v du over dt plus u dv all over dt. That's now the product rule general equation. So let us find the values for v and u. So firstly, we will say let u be equals to the mu plus sigma squared t, then du over dt is going to be sigma squared, sigma squared. Then we will have v as our v is going to be the exponent mu t plus a half sigma squared t squared. Then we say we will have dv over dt being given us. Now it's going to be mu, plus sigma squared t. Are we getting it? Yeah. Let us now use the product rule formula to have the whole of this. Then what to do is we replace in the general formula for finding product rule. Then it's going to be v, which is the exponent mu t plus a half sigma squared t squared. We multiply by du over dt, which is sigma squared, plus we say u, which is mu plus sigma squared t. This one is our u. Then we dv over dt, which is also still mu plus sigma squared t. Sigma squared t. In reaching there, we will therefore say, but this one is all derived by t is equals to 0. Here, it's a two-way how we can derive this, but we can still say we can expand this one, then we replace the value of t by 0, or you replace the value of t directly. You will still arrive to the last answer. But because of that, let us have to replace directly. Then our expected value of x squared will be given as, this is going to be the exponent, mu times 0, it is going to be 0 plus. This one is also 0. Then we have sigma squared. Are we getting it? Plus, this one is mu, plus, this one is going to give us 0. Sigma squared t is going to give us 0. Then this one is going to be mu. This one also going to give us plus 0. Are we getting it? Then we have to recall that any number raised to 0, it's the same as 1. So this one is going to be 1 multiplied by sigma squared, getting it, plus mu. This one is going to be mu into mu. So this one is going to give us mu squared. Are we getting it? So our expected value of x squared is giving us sigma squared plus mu squared. But what do we write the function or the formula of getting the variance? We got it as, this was the formula, this one. So we have already found this one. And this one we already found it as mu. So it's going to be variance of x is always given by the expected value of x minus the expected value of x squared. So already this one we have found out this one. So we have sigma squared plus mu squared minus mu but squared. Are you getting it? So this one will cancel out this one. So our variance will be giving us sigma squared. That's how we derive the mean and variance using the moment generating function. Thank you for watching and bye bye.